Hello everyone. In this video, we're going to discuss about how to construct regular grammar for given finite automata. So in the question, they will give the finite automata, DFA or NFA. So for that finite automata, we need to construct a regular grammar. So for that, we have some procedure. So let's see the procedure first. So this is the procedure. So first consider m is equal to, they have given some finite automata. Already we know the finite automata can be represented using 5 tuple notation. So the first one is set of states here. So that is Q, which we are representing using uh, different states Q0, Q1, Q2 and so on, Qn here. So these are the states, and this is sigma input, delta transition function, Q0 is the initial state, and F is the final state. So now for this, the equivalent grammar, so regular grammar. So how to represent this regular grammar? So generally we know the regular grammar can be represented using VTPS. So what is V? V is nothing but the vertices here, set of vertices which are equivalent to states. So that we will discuss here. Vertices. So in this vertices, what are the vertices we are taking here? A0, A1 and so on, A. And T is nothing but the terminals which are equivalent to sigma. That means input signals. So that's why instead of T, what I'm writing here, I'm writing sigma only. And P is nothing but the production rules which are equivalent to transitions in the finite automata. So here the transition is delta, but here we are representing the string transitions as production rules. So that's why I'm indicating as P. And next is A0. A0 is the start symbol, which is nothing but the initial state in our finite automata. So that is nothing but the Q0 here. Now, so here they have given the description where P is a set of production rules can be defined by the following rules. So we need to convert the given finite automata in a regular grammar, right? So same finite automata, we need to convert it into regular grammar. So while converting it, we don't get any problem with these three things, V, T, yes. So there is a problem only in constructing production rules, right? There is nothing but a set of vertices which are equivalent to set of states. So whatever the states you are using as it is, you can write them. Otherwise, you can rename them. And coming to T, terminals. So same as sigma, that means set of input symbols. And coming to here, A naught, which is nothing but the initial state. Whatever the initial state you're using for your finite automata, same thing we can consider here as a stat symbol. The only problem with the P, production rules. So if I have the transitions, how to transform them into production rules by following these rules. For example, if AI tends to AJ is a production rule. So when I need to write this production rule, so when I can write this production rule, if QI on A is going to QJ, if QI is going to QJ, then what I can write? I can write QI on A, it is going to QJ. Like this I can write. So instead of Q, you can take A here. So what I'm taking here? AI on A, where it is going to J. So where Qj is not belongs to F, that means Qj is not a final state. So for all the normal states, you need to follow this transition rule. And coming to if it is a final state, if Qj is final state, so if the target is final state, so AI tends to AAJ. So if AJ is a final state, then you need to add one more transition here, one more production rule. What is that production rule? AI tends to A. That means AI tends to A without this AJ. When we need to add this production rule, only if AJ is final state, then you need to add this production rule, additional production rule. So are the production rules if QI on A is going to QJ, where QJ belongs to capital M. So if QJ is final state, then only you need to add this extra additional production rule. Then thus the given grammar will be accepted by DFA. Yeah, right? So this corresponding grammar, after following all these rules, if we can generate a grammar that will be accepted by the given finite automata. Right. So we'll see some problems here. So construct regular grammar. So construct regular grammar for the given DFA. So they have given the DFA, but this we need to construct the regular grammar. So what is the regular grammar? So first we will take a Q set of Q states. What are the states we have? Q0, Q1. So this is equivalent to vertices, right? So vertices, what we are taking, vertices are taking as A0, A1. And what is sigma for your problem? For our problem, the sigma is A comma B. So T will be A comma B only. T is nothing but the terminals, V, T. So productions we will write, and yes, S is nothing but the starting symbol. So what is the initial state for this problem? So for this finite automata, Q naught is initial state. So instead of Q naught, what will be the start symbol for our problem? It is A naught. So now we need to write the transition rules. So how to write the transition? Q naught on A is going to Q naught only. So Q naught on A is going to Q naught only. So how to write this? A naught on A, it is going to A naught. So this is one production rule. A naught on A, it is going to A naught only. But A naught is not a final state. A naught is not a final state. Now, next is Q naught on B is going to Q1. That means A naught on B is going to A1. But A1 is a final state. A1 is a final state. That means you need to add one more additional transition. What is that? A naught tends to B. And next transition is Q1 on A is going to Q1. Q1 on B going to Q1 only. See, Q1, that means A1 on A is going to A1, whereas A1 is a final state, so you need to add A1 tends to A additional production rule. Then what is another one? A1 on B is going to A1, whereas A1 is a final state, so A1 tends to B. So these are all production rules which we will get for this problem. So how many productions will we are getting? 1, 2, 3, 4, 5, 6 and 7. Totally 7 rules we are getting. See here, so here in the solution we are just writing all the symbols. So G is equal to VTPS. Then after this I'm just writing all the production rules here. So whatever the rules we have discussed here. So all these rules we are representing in the next slide too. So this is first problem. And coming to second problem, so construct the regular grammar for the given finite automata. So this is also similar. So first you need to write all the formats for the given finite automata. The first one is Q. What is Q here? We have 4 states. So Q1, Q2, Q3, Q4. Then what is our V will become A1, A2, A3, A4. Then what about our sigma? The input symbols are we are using A comma B. Then here the terminals will become A comma B. We'll write the production rules. And coming to starting symbol, what is Q naught for your problem? For your problem, Q naught is Q1. So for our problem, a starting state will become A1, right? A1 will become the starting state. So now we'll try to write the production rules. So the first production rule, Q1 instead of Q1, Q2, we need to consider A1. Okay. So A1 on A1 on A, it is going to A3. But A3 is not a final state. So we need to check the right hand side states. Okay. If it is a final state, we need to add a additional transition. Then A1 on B, A1 on B, where it is going A2. And A2 is also not a final state. Next, we'll go with the A2. A2 on A. A2 on A is going to A3, whereas A3 is not a final state. Then A2 on B is going to A4, but A4 is a final state. A4 is a final state. So along with this, we need to add one more transition. A2 tends to B. So by combining these two, you can simply put a slash here. Okay, no need to write the two transitions here. B A4 slash B. Simply you can write like that. A2 is over. Now coming to A3. A3 on A is going to A4. A3 on A is going to A4, but A4 is a final state. That means you need to add one more transition. What is that? A3 tends to A. So instead of writing like this, you can simply put a slash and you can write A. A3 is over, not over. A3 on B is left over, right? So A3 on B, A3 on B, it is going to A2, whereas A2 is not a final state. Now last state is A4. A4 on A is going to A4 only. So where A4 is a final state, so you need to add one more transition. And then A4 on B is going to A4 and it is a final state, so you need to add one more transition B. So these are all rules, production rules we are getting for this problem. So these are all the production rules we are getting for this problem. So these are all homework problems. I hope everyone is clear with this video. By seeing that concept, by seeing this video, you can able to solve these problems. We have 1, 2, 3, 4. We have 4 problems here. Try to solve these problems. Thank you.